right, this would be day 2. So these are really just practice questions that go with recognizing information on a line plot. So this first paper here, it says a baker has sacks of flour with lengths as shown below. Circle the line plot that represents his data. Just slow down a second. This one says that it's 10 one time. This has 2 X's on 10, which means I should see 10 twice. This has 3 X's on 10, which means I would see 10 3 times with his data. This also has 3 X's on 10. How many times do you realistically see the number 10? Just twice. So you find something that you can fact check and you move on. Done. Easy point. A greenhouse worker recorded the amount of water remaining in different watering cans after plants were watered. The fractions below show the amount of water remaining in each watering can in gallons. Create a line plot of the data. First thing you need to do is figure out how many pieces this line plot's cut into. You do not start at the first whole number. So you're going to start counting at the first notch after the first whole number. And you're going to count all the way through to the second whole number. So this is 1, 2, 3, 4, 5, 6, 7, and 8, which means this line plot is cut into eighths, which means we're going to have to change every single one of these fractions so that the denominator is actually 8. It might be easier for you to take a second and label the line plot. If it's cut into eighths, that's 1, 1 and 1/8. I'm going to do every other one just so that I can see it. 1 and 2/8, 1 and 3/8. 1 and 4/8, 1 and 5/8, 1 and 6/8, 1 and 7/8. This would be the same as 1 and 8/8. If this is 2, that's 2 and 1/8, 2 and 2/8, 2 and 3/8, 2 and 4/8, 2 and 5/8, 2 and 6/8, 2 and 7/8. This would be 2 and 8/8 or 3. If you have to get them to be eighths, because you have to stick them all on the same line plot, could you do the backward C and then find me and get me to 8 with common denominators, doing the same thing on the top and the bottom? 100%. Do you have to do that? Absolutely not. You have to get to 8. So I know that 2 times 4 is 8. The only thing I need you to remember is equivalent means equal. Whatever you do on the bottom, I need you to do the top. If this is 1.5, well, 1 times 4 is 4. 2 times 4 is 8. It's the same as 1 and 4/8. This is already in eighths, already in eighths, already in eighths. This is the same 1.5. I just did it. 1 and 4/8. Already in eighths. This is 1 and 1/4. But 4 times 2 is 8. 1 times 2 is 2. It's the same as 1 and 2/8. This is 2.5. But 2 times 4 is 8. And whatever you do, so sorry, on the bottom I need you to do to the top. So instead of 2.5, 1 times 4 is 4. 2 times 4 is 8. If you can quickly do that, now you're just going to plug stuff in. You can either put an X there, you can put a dot there. I have 1 and 4/8. So I know that 4 would be between 3 and 5. So if that's 1 and 3/8, this is 1 and 4/8. I use that. I'm going to cross it out. That's 2 and 1/8. Going to put my X there. Going to cross it out. I used it. 2 and 1/8 again, another X. 1 and 5/8, put an X there. 1 and 4/8, because it was 1.5, so I'm going to find 1 and 4/8 again, and I'm going to put an X there. 1 and 3/8, I'm going to find it, put an X there. 1 and 2/8, I'm going to go find it. It's between 1 and 3, because it would be 2/8, and I'll put an X there. And then I have 2 and 4/8. So if that's 2 and 3/8, this is 2 and 4/8 because that's 2 and 5/8. The only thing I would ask you to double check is you have 1, 2, 3, 4, 5, 6, 7, 8 boxes. So make sure you have 8 X's or 8 dots. I got 1, 2, 3, 4, 5, 6, 7, and 8. Number 2 is done. 3 says, what is the approximate, which means exact, change in the number of deer between year 3 and year 7? But they want the change in the number, and the change in anything is simply the difference. They are asking about year 3 and year 7. is the approximate change in number of deer between year 3 and year 7? Well, here's year 3. I don't have year 7. So maybe are they asking me to recognize? So that goes up by half. That goes up by 1. That's 1.5. Okay. That's annoying. That's also 1.5. That's annoying. All right. Well, I think what they're asking us then, because I didn't make this question, I just found it. Between 1 and 1.5, it's going up by half. Okay. 1.5 is 0.5 bigger than 1. Between 1.5 and 2.5, that's a difference of 1. Between 2.5 and 4, 2.5 to 3.5 is 1. So 3.5 to 4 would be 1.5. 4 to 5 is 1. And then 5 to 5.5 would be 0.5 more. So 5.5 to 6.5 is 1. Okay. So am I to assume it's going up? I don't know. This is weird. What is the approximate change in the number of deer between year 3 and year 7? I don't love this question. I thought maybe it was going to be a pattern. I thought maybe it was going to be 0.5, 1, 1.5, and then like 2, 2.5, and then the next realistic thing would have been 3. But now I just have 1.5, 1.5, 1.5. So I can't imagine it would just be 1.5 again. But it's asking me for year 7. I'm going to change this just for the simple fact that I want to get this done. I'm going to say year 6 because I don't exactly know what they want. I didn't make this question. So for right now, let's say that year 6 shows 7 deer. Okay? 7, if you're going to put a decimal on it, stick it at the back. I'm going to have to look into this question and see what they want. Year 3 for right now is showing me that it was 2.5. So at the very least, if we can line up decimal points and stick zeros where they need to go, I'm just going to change it from year 7 to year 6 and look into what they actually wanted us to do. But you can't spend $5 if you're broke. So you're borrowing, that's 10. 10 minus 5 is 5. Hopefully you stacked them. 6 minus 2 is 4. And that's what I would have. It's saying in hundreds, so you can just put hundreds. I got to look into it and see if they wanted us to recognize a pattern or what. But for right now, we're moving. Claire. Claire studied the amount of water in different glasses. The data that she collected is below. Use her data to create a line plot to show the amount of water in the glasses. If you're making a line plot, then you have to figure out how many pieces you need it cut into. Look at your denominator. What's the greatest denominator you have? Should be 8. But if the greatest denominator we have is 8, well then we're going to cut it into 8 pieces. Since none of these have a whole number whatsoever, that means that you're going to give me a line. Doesn't matter if it's lumpy and crooked, mine is 2. If none of these have a whole number, that means everything is between 0 and 1. Which means 1 has to be your 8th mark. You don't start here. This would be 1, 2, 3, 4, 5, 6. I'm going to move this because mine's going to be not even. I don't like that. This would be 7. And I'm going to move my 8th one over just so it's a little bit more even. I'm going to say that that would be 8. So that would be where 1 goes. I need you to remember, you never start counting at the first whole number. You start at the first notch after the whole number, and you count all the way through to the next whole number. So if this is 0, this would be 0 and 1/8, or just 1/8. This is 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and this would be the same as 8/8 because 8 divided by 8 is 1. Anything that doesn't already have a denominator of 8, you're making an equivalent fraction for. So you get yourself from 2 to 8, 2 times 4. Whatever you do on the bottom, I need you to do to the top. 4/8, you go find it, you put a piece of data there. This is not already 8, so you're going to have to make me an equivalent fraction. 4 times 2 is 8. 1 times 2 is 2. You find 2/8. You put a dot there. This already is at eighths. I'm going to put a dot at 1/8. Get you to eighths. 4 times 2 is 8. 1 times 2 is 2. So this gets me 2/8. I'm going to put another dot at 2/8. This is the same exact number. So 4 times 2 is 8. 1 times 2 is 2. I'm going to get another dot at 2/8. This is already in eighths, so I'll find 5/8 and put a dot there. This is already in eighths. I'll find 3/8 and put a dot there. This is already in eighths. I'll find 5/8, put another dot there. 1/8 is already in eighths. Put another dot at 1/8. 1/8 again, put another dot there. The only thing I need you to double check is, do you have what you need? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data, which means you need 10 dots or 10 X's. That's 3, 4, 5, 6, 7, 8, 9, and 10. Literally done. You're done. All right. These would be little questions that I found. I honestly haven't read through them yet, so this could go one of two ways here. Could be good, could be a mess. It says the line plot below shows the distance students lived from school in miles, which means that each one of these X's realistically is a kid. How many students are included in the line plot? But if each X is a kid, you're literally counting the X's. How many kids did they ask? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. I count 20 X's. I've got 20 kids. I'm moving down. The line plot below shows the lengths of Julie's hair ribbons. What is the total length in inches of the 3 shortest ribbons? The 3 shortest would be the 3 smallest pieces of data. This is the smallest. This is the next smallest. This is the third smallest. It's the first 3 X's. So in order for you to figure out what that number is, you got to figure out how many pieces that line plot is cut into. You do not start counting at that whole number. You start at the first notch after the first whole number, and you count all the way through to the next whole number. This is cut into 1, 2, 3, 4 pieces, which means that when you make the fractions, your denominator has to be 4. So if this is 21, then this is 21 and 1/4. It's tiny, so I'm going to put it off to the side. If this is 21 and 1/4, then that's 21 and 2/4. And I have that number 2 times, so I'm going to use that number 2 times. We are going to add these up, but I know, sorry, it's really fuzzy. Okay, there we go. I know that 2/4 and 2/4 is 4/4, and 4/4 is another whole. So I'm going to put that whole up here, which means I only have 1/4 here. This extra came from me combining those fractions. 2/4 and 2/4 would be 4/4, and 4 divided by 4 is 1. So my 1's up here. 1, 2, 3, and 4. 2, 4, and 6. So I have 64 and 1/4. Moving down. Well, that's a big one. All right, let me go up here then. The line plot below shows the height in feet of the girls on the 5th grade basketball team. What is the difference, tells you what to do, between the tallest girl and the shortest girl? If each one of those X's is a girl, that means that there are 3 girls that are 4 feet tall. There's 1 girl here, 1 girl here, 1 girl here, 3 girls here, 3 girls here. You're not using all 3 of those girls. They just want 1 of the tallest girls, 1 of the shortest girls, which means 1 of these and 1 of these. And that's it. You got to figure out how many pieces is this line plot cut into. So I'm not going to count that first whole number. I'll start counting after, and I'll count all the way through to the 5. This is cut into 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces. So my shortest girl is just at 4. My shortest girl is at 4 feet, but they want the difference. So I have to take something away. This would be 4 and 1/8. 4 and 2/8, 3/8, 4 and 4/8, 4 and 5/8, 4 and 6/8. This would be 4 and 7/8. That's one of my tallest girls. If this is just a whole number, just 4, then there is no fraction. 0/8. You don't have to do the backwards C. They already have common denominators. 7/8 minus no eighths means I still have 7/8. You walk in with $7, nobody's robbing you, you're coming out with $7. You're not spending anything. 4 minus 4 is nothing. So you can either put 0 and 7/8, or you can simply put 7/8. The line plot below shows the amount of water in liters that students drank during field day this year. How much water in liters did they drink all together? All together means that you are adding up every piece of data there is. So unfortunately, I see 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 X's, which means we're going to have 12 numbers that we have to combine or add together. So I'm going to draw a little arrow for myself that goes towards the bottom so that I have some room here. I need you to figure out how many pieces is this line plot cut into. You got to be able to take numbers off. You do not start counting at the first whole number. You need to start at the notch after the first whole number. And you count all the way through to the next whole number. So I have 1, 2, 3, and 4. It's cut into fourths. So I have 2 X's. Actually, let's do this. If that's 1, that's 1 and 1/4. 1 and 2/4. This would be 1 and 3/4. 1 and 4/4 is 2. This is 2 and 1/4, 2 and 2/4, 2 and 3/4, 2 and 4/4 is 3. This would be 3 and 1/4, 3 and 2/4, 3 and 3/4, and 3 and 4/4 would be 4. If you have 2 X's at 1, I'm going to list 1 twice. I have 2 X's at 1 and 1/4, which means that I'm going to put 1 and 1/4 twice. I have an X at 1 and 2/4, so I'll put that down here. My next X would be at 2. I have 2 X's at 2 and 1/4, so I'm going to combine that. Or not combine that, but write that twice. I'm sorry, I don't know what I'm saying. I have an X at 2 and 2/4. I don't have anything at 2 and 3/4, but I do have an X at 3. Nothing at 3 and 1/4, but I do have an X at 3 and 2/4. And I have another X at 3 and 3/4. My only thing to you would be just to double check how many X's you have and make sure you've written that many numbers down here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right. Easiest thing for you to do would be for you to combine fractions. So if you know that 4/4 is a whole, put stuff together. 3/4 and 1/4 is 4/4. So that's an extra one, an extra whole. Get rid of fractions. I have 2/4 and 2/4 would get me a 4/4. That's a whole. I have 2/4, 3/4, 4/4. 2, 3, and 4. That's another whole. So the only fraction that I have left is 1/4. So whatever my answer is going to be, I only have one fraction there. So 1/4 is left over. And then you're adding whole numbers. 1 plus 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3 plus 1 plus 1 plus 1. Figure that out for me. I count 25. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So how many liters did all the kids drink together? I have 25 and 1/4. This one says that Wayne measured the lengths of wood that he had in his garage to build a doghouse. Use the line plot to the right to answer the questions. What is the length of the longest piece of wood? Well, the length's on the bottom, and everything's already labeled, which is awesome. Where this says 1 1/4 and then 1 1/2, 1 1/2 is the same as 1 2/4, if you want to make that easy for yourself. Because then it says 1 3/4, that would be 1 4/4 or 2. 2 1/4, 2 2/4 is the same as 2 1/2. 2 3/4, and then 2 4/4 would be 3. The length of the longest piece, the biggest number that actually has data there, 3. And everything's being measured in feet, so 3 feet. How many pieces of wood are at least 2 feet long? You're going to see at least on the exit ticket questions. At least 2 feet means 2 or more. So it would be any of these. There are at least 2 feet. They're 2 feet or bigger. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. 14 pieces. What is the difference, tells you what to do, between the longest and the shortest piece of wood? Well, the longest piece, the biggest piece of data, the biggest number that has data there is 3. And the shortest piece, the smallest number that has data there, is 1 1/4. It might be easier for you to rewrite 3. If this is 2 1/4, 2 2/4, 2 3/4, 3 would be the same as 2 4/4. That way you don't have to put 3 over 1. That way you're not doing the backwards C. You're not finding a common denominator. You're giving yourself the common denominator. They're on the same line plot. They have a common denominator. Your denominator is 4. 4 minus 1 is 3, and 2 minus 1 is 1. So the difference would be 1 3/4. It says, if he needs 35 feet of wood to complete the doghouse, does he have enough wood? As annoying as that is, I did not read that one. You're going to have to add up everything. They're saying, if he needs 35 feet, does he already have more than 35? So I'm going to bring this down here on this side. So I'm just going to make a line here. I have 2 x's at 1 1/4. So I'm going to put 1 1/4 twice. I have 2 x's. It said 1 1/2, but that's the same as 1 2/4. So I'm going to write 1 2/4 twice, just so everything already has the same denominator. Nothing was at 1 3/4. I have the whole number 2 3 times. So 1, 2, and that would be the third one. I have 2 1/4 3 times. So 1, 2, 3. I have 2 1/2 or 2 4/4 twice. So I'm going to put 2 2/4 twice. I have 2 3/4 4 times. This is my third. This is my fourth. And then I have the whole number 3 twice. Honestly, combined fractions, if you know that the denominator is 4 and 4/4, 4 divided by 4 is 1, put the fractions together to make 1. I'm going to say that 3/4 plus 1/4, that's 1. 3/4 and 1/4, that's another 1. I have 3/4, so I have another 1/4. I do, so 3/4 and 1/4, that's another 1. 3/4 and 1/4, that's another 1. I have 1/4, but I don't have another 3/4, but 2/4 and 2/4 is another 1. I'm going to have to go down over here. What do I have left? 2/4 and 2/4 is another 1. And the only fraction I have is 1/4. So whatever the total is going to end up being, I know that I have a fraction left over, and that fraction is 1/4. I don't have any more fractions. I don't. All right, so now we're adding whole numbers. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, and 40. He needs 35 feet. They're saying, does he have enough? Yeah, he does. He does because he has 40, and 40 is bigger than 35. All right. 4 more. We're almost done. Mrs. Smith collected data to show the weight of potting soil brought in by each of her students. Sorry, I'm up here. Use the data to create the line plot. All right, the only difference is that these are decimals, okay? So I want you to think about decimals as quarters, okay? So you have 1 quarter. You have 2 quarters. You have 3 quarters, and then finally you'd have $1. So if you look at this, this will be cut into fourths. Start counting here, stop counting here. 1, 2, 3, and 4. Because anytime they're looking at decimals, you have to think about quarters. So if this is 0, well, it's $0 and a quarter. That would be 50 cents. That would be 75 cents. That's $1. That's $1.25. $1.50. $1.75. $2. $2.25. $2.50. $2.75. That's $3. If you can do that, you're putting dots or X's. This is weird and blurry, but that says 1.5. So if that would be 1.5, that's the same as $1.50. So you find $1.50, you put a dot there. 1.5 again is another $1.50. 0.75, 75 cents. 2.5, 2.50. 0.75, 75 cents again. Whole number 2. Whole number 2. 0.75, 75 cents again. 1.5, 1.50. Where's my 150? 0.75, 75 cents again. Whole number 2. Whole number 1. Whole number 1. Whole number 2. Whole number 2. 0.5 is 0.50, so $0.50. That is 4, 8, 12, and 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. All right. How many students brought in more than 1.5 or 1.50, but less than 2.5 or 2.50? They want any one that is more than 1.50. So more would be this. Doesn't say equal to 1.50. It says more than. And less than 250. Well, if that's 250, this one's less. So between those two spots, how many dots are there? Should be 5. How much soil was brought in by all the kids? That means you're adding up all of those, but they're not even fractions. They're decimals. You can do that. Stack them. I have 1. I'm going to have to... All right, you're going to have to get maybe a piece of paper. I'm just going to pull a sticky note. All right, I have 1.5. You're adding up decimals. They want you to add up decimals, so just stack them, please. I have 1.5 again. I have 0.75. I have 2.5. I have 0.75. I have the whole number 2. That's what 2 is. I have the whole number 2 again. I have 0.75. I have 1.5. I have 0.75. Ugh, this is annoying me. Okay, let's see. I need longer. I have 1.5. I have 0.75. I have the whole number 2. I have the whole number 1. Sorry, probably not even looking at my note anymore. Whole number 1 again. Whole number 2. Whole number 2. And then 0.5. Might be easier for some of you if you just go ahead and draw in the place value lines. Make sure all your decimals are stacked. Any weird opened spot, just stick a 0 there. I know it's annoying. It is so annoying. I'm annoyed right now too, but you can add decimals, so no big deal. All right, that is nothing. 5, nothing. 5 and 5 is 10, 15, 20, 25. So 5 on the bottom, a little 2 up top. I'm going to do the 7s first, I think, and maybe just do some stuff off to the side. I have 7, 1, 2, 3, 4, 5 times. So 7 times 5 is 35. So 5 more would be 40. That's 45. That's 50. This would be 55. Plus those 2 would be 56 and 57. I'm going to do the 2s first. I have 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17. That was the 5 up top. 18, 19, 20, 21, 22, 23. So I have 23 and 75 hundredths. Everything says kg, kilograms. Kilograms. All right, let's see what this one wants. Jim kept track of the number of games his football team won each year. Okay. How many games did his football win? Nope. Did his football team win in 2017? Well, here's 2017. Sorry, that's my big fat hand. Here's 2017. Games won. It looks like 7. It's kind of hard to see. Did they win more games in 2015 or 2019? Well, here's 2019. Looks like that's at 6, maybe? 2015's at 5, so 2019's higher. They won more games in 2019. How many more games did they win in 2016 than 2015? Well, how many more is subtraction? So they want you to subtract. 2016 is up at 10. 2015 is at 5. So 10 minus 5 is 5. Phew, 2 more. All right. The data in the table shows the population of Groveland, Florida from the year 1990 to 2020. Use the data to complete the line graph. All right, these are so tiny. I would assume that these are going up by, I don't know, it's going to say 2, but I don't think that's right. All right, just due to the sheer fact that I printed this terribly, cross that out. I can't with that. All right, what does this one say? Jennifer counted the number of ducks she saw on her way to school each day. The results are listed below. Use the data to create a line plot. All right, good news would be all of these are whole numbers. There's no decimals, there's no fractions, there's nothing. So the smallest number I see, I have a 5. So I think the smallest number is 5. And the biggest number that I see looks like to be 13. So at the very least, that's got to be 13. So that could be 12, 11. Sorry. I would say that's 10. That's 9, 8, 7, 6, 5. That could be 4. That could be 3. That could be 2. That could be 1. Whatever. It doesn't matter. Fine. Actually, you know what? That's not going to work. It's not going to work because I can't have random things in the front. Well, my smallest number is 5, but I had enough for... All right, so let's just start at 1. 1, that's 2, that's 3. That's 4, that's 5, that's 6, that's 7, that's 8, that's 9, that's 10, 11, 12, 13. Even though there's no 14, 15, 16, or 17, I'd rather have numbers labeled in the back than weird open spots in the front, okay? So she saw 6 ducks one day. She saw 8 ducks another day. She sees 12. She sees 14. She sees 5. She sees 6 again. She sees 7. She sees 8. She sees 12. How to find it? She sees 11. She sees 12 again. She sees 5. She sees 6. 6 again. I've got 8. I've got 11. I've got 8 again. I have 7 again. I have 6 again. And finally 13. All right, just count them. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, cool. They're all there. How many days did she count the ducks? Well, we just counted 20 numbers and 20 dots, so she does it for 20 days. How many days did she see 6 ducks? Well, here's 6. I have 1, 2, 3, 4, 5 dots there, so 5 times. How many days did she see more than 10 ducks? So it doesn't say 10 or more, it's more than 10, which means it's 11 and more. So I have 1, 2, 3, 4, 5, 6, and 7 dots there. So I'm going to say 7. Sorry, that was long-winded. All right, there should have been 3 papers. If you belong to me, you're folding all 3 papers. I'm saying that because I'm pretty sure Miss Diaz's kids are going to watch this too. This is going to be, how did we label the other one? I don't remember. All right, data on a line plot. Data on a line plot. Day 2. And you're going to write that for all 3 papers. Data on a line plot, day 2, 3 times over. Here's what you're going to do for me when that's done, because you're going to glue these on the next 3 pages you have. Let me move that. Most of that was me doing it, and I know you people, okay? Most of you probably just watched it and filled stuff in. That's fine. Just recognizing that number 1 doesn't work because it was literally one from our notes, so that's funny. All right, you're going to end up doing this paper. When you get this paper, just cross out number 1 because we've already done it, and I can't stand to do it again. Which means you have 2 things here. 2 and 3. Oh my gosh, what have I done? All right, forget it. I was going to have you do a paper and see how you do, but what's the point? 2 of them. Clearly, I'm losing it. 2 of them we've already done. All right. I do have an exit ticket for you for day 2. It is simply 4 questions, and most of it is, I don't know. I made it a few days ago. I think it was pretty basic. What is it? Let's see. Exit ticket day 2. Looks like what? Oh yeah, I did this morning. Okay, easy breezy. Y'all can do that. No problem. There's only 4. You can do it. I promise. They're recorded. Okay, should be fine. Fractions, they're all on the same graphs. They already have common denominators. Decimals, line them up, please, for all the future gray hairs I'll ever have. These all have common denominators. Decimals, you'll be fine. You'll be fine. All right, easy breezy. Do that for me. Exit ticket day 2. It should be in the red folder for us.